Welcome to the 6th unit in our MCT4C course. Today we're going to review some of the things that we talk about when we're talking about periodic functions. When we get to sinusoidal functions, they're just a special type of periodic function. So our goal today is that you can identify key characteristics of periodic functions from their graphs. And in your homework, you're going to be actually trying to relate those key characteristics to the actual physical feature in context of a problem. So first of all, vocabulary. Periodic function is just a function that has a graph that repeats itself. So you could just take a section of your graph, you could do a copy, and then you could slide over left or right and do a paste, and you're going to get the same cycle or the same part repeating itself over and over again. A cycle is that smallest complete pattern that does repeat. It's the part that you would have to do a full copy on. You could slide over left or right, and then you could do paste, and then continue to do that left or right and paste, and you'll just have it repeating that value over and over again. A period, the period for your periodic function is the horizontal length of one cycle. So it's the distance it takes horizontally to complete one full repeating pattern. The axis of the curve is that horizontal line that is halfway between the maximum and the minimum values of your periodic graph. So it really is that middle point between max and min. So if you think of midpoint, your midpoint would be taking the average of those two things. So it is a horizontal line, the slope will be 0. So when we state its equation, it's going to have this format. Your equation will be y equals, and it's a horizontal line, there is no x, it's just a constant number. And to get that constant number, it's the midpoint, or the average, between the maximum and the minimum. So you take your maximum value, you add your minimum to it, and then you get that total and cut it in half. You're adding, it's like taking two different test marks, you add them together and divide by 2 to get that middle point, or your average. The amplitude is your vertical distance between the axis of the curve and either your max value or your minimum value. It really is, if you took the whole distance between max and min and then cut that in half, that will be your amplitude. Now to get that, I'm going to use the letter A for amplitude. The actual distance between your max and min, instead of adding those together, you're going to take your max and subtract your min. That will give you how many units there are between those two values. And then you're going to take that distance, it's going to calculate a distance, and cut it in half. So you divide it by 2. And that will give you your amplitude. And as I said at the beginning, a sinusoidal function is a type of periodic function. It's a subset, but it's the one that has the nice, smooth, symmetrical waves. So if you have your x and y axis, it's the one that gives you a nice up and down wave-like, symmetry-like pattern to your graph. All right, not the best hand-drawn picture, but hopefully that triggers your memories. Okay, moving on to some examples of identifying these things. Okay, so I have a periodic function here. It's not sinusoidal because it doesn't have the smooth waves. It has some jiggity jags here, but again, it does have that repeating pattern that you can see over and over again. So if I want to identify some of that information that we had earlier on, one cycle, depending on where you start, I'm going to outline in red here. Actually, let me try a different tool. There we go. I'm going to try using a highlighter, highlight in red here. If I start here, this is all brand new. I'm not repeating yet, continue on until I get to here. If I continue on past where x equals 6, I would be then following a new, like the same pattern, but it would be a new cycle. So my outline in red or the outline in green would be one exact cycle. So let me just label that on here so that you have some picture of what the things are in terms of the vocabulary up above. That is one cycle, okay, or the green here, that would represent one cycle. Okay, and if I look at one cycle, in that cycle, the maximum value that we have overall, it reached a maximum of 5, and that's on your y here. So the highest point it got to was 5. If I look at where the lowest is here, my lowest value is -5. Okay, the amplitude in this case would be if I take the difference between those two, 5 take away negative 5 would give me 10 units difference. So 5 take away the 5, take away the negative 5. That would give me 10 units difference, and then when I cut that in half, I get 5. So my amplitude in this case is also 5. The axis of the curve, the axis of this graph, in this particular case, horizontal line, the horizontal line that's exactly halfway between the max and the min happens to be the x-axis. So this is the axis of the curve, axis of the graph or curve. It's not really a curve in this case because it's jaggedy of the graph. It's just the x-axis, which has the equation y equals 0. The slope is 0 and the y-intercept is 0. So your equation is y equals 0 for that. The period, that is your horizontal length of one entire cycle. So the period, if I start my cycle here and end the cycle here, that red cycle, the period is 6 units long. So the period is that length here, from there to there. From there to there. Those are not number ones, those are just sort of divide lines of where that period goes to. So the period is 6 here. It's 6 units long horizontally. I'm also going to mark on here amplitude. So the amplitude, the A for amplitude, it's that distance between the max to the axis of the curve, or the min to the axis of the curve. So those A's written on there, that represents the amplitude, A for amplitude there. Domain. Now, I'm going to assume, I forgot to put arrows on the ends of this, but if this continues its pattern as we go, the domain, we're not leaving any x values out. We're just going to say that x belongs to the real number system. Okay, but we clearly are not using every single y value. We're only going as high as 5 and as low, so as high as 5 and as low as negative 5. So when we have our y as an element of the reals, we're also going to have such that negative 5 is less than or equal to y, and y is less than or equal to positive 5. Okay, so your y is sandwiched between negative 5 and positive 5. Okay, so those are the key ideas or the key characteristics that we should know or be able to identify from a graph of a periodic relationship. All right, continuing on, there's an example B. Why don't you give that one a try, see if you can identify those things, as well as for example C, and I will take those up on the next video. Or should I say the next page. All right, looking at our graph here, it looks like this one also has a maximum value of 5, but this time the minimum only goes as low as negative 3. The amplitude, again, I can add those together, subtract those, 5 take away negative 3. So that gives me a total of 8 units between the maximum and the minimum, and then cut that in half and I get 4. So the amplitude is here is 4. The equation for my axis, I want to find that midpoint between those two, so I'm going to add 5 and negative 3. That gives me a positive 2, and divide by 2, that gives me 1. So my equation for my axis would be y equals 1. So this is, I'm just going to draw that in there. There's my equation for my axis for my graph, y equals 1. The amplitude is between the max and the axis of the curve, so that amplitude is 4 units, or you could see it here as well. This is 4 units from the min to the axis of the curve. The period in this case, I want to look for how long it takes to complete one cycle. Now, you just have to pick a spot. You don't have to start at 0. You just have to count how many units horizontally it takes to cover one entire cycle. So if I wanted to go from this minimum spot, I'm just going to highlight this. If I look at that as one cycle, I started at negative 2 and ended at positive 5, so that's 5, 6, 7 units long horizontally. So the period is 7. Oops, that is a highlighter, but that's okay. I hope you can read that. So the period, that's that length across here. It's 7 units. The domain, again, assuming this goes on forever and ever in both directions, it's just going to be x as an element of the real numbers. And then as far as our range goes, the y values are all real numbers as well because they're all joined together, but we bottom out at -3 and we top out at +5. So our y values are sandwiched between those two values. All right, the last example here, I need to figure out what my scale is. It takes 1, 2, 3, 4, 5 blocks to make 10, so each block is worth 2. So my maximum value looks like it's at 18. My minimum then is at 2. The amplitude, there's 16 units between those two. 18 take away 2 is 16, divided by 2 would be an amplitude of 8. My equation of my curve, I would add those together and get 20 divided by 2 will be 10. The period, I've got to trace that out. Let's see how long one cycle takes. I'm going to go from min to min here. So up, down again. Okay, so it went from 270 back to this spot. And there's 3 blocks to make 90, so that makes every one of these 30. So if I go from 30 to 270, that distance between them, I can be subtracting those. 270 take away 30, that's 240 as the period value for that. So that's a period of 240. Domain, again, assuming it goes on forever, it's just any real number. And the range tops, our y values are topping up at the 18 and bottom out at the 2. So we go 2 is less than or equal to y is less than or equal to 18. Okay, and that number at the beginning here is a 2, not a z. All right, hopefully that makes sense and we agree with our answers here. Use your technology on that last example and see if you can remember what the graph for y equals sine x looks like and what its characteristics should be.